Okay guys, we're going to do more triangles. So today we're talking about proving triangles are congruent by what's called angle side angle or angle angle side or hypotenuse leg. What we've learned before is side angle side, side side side. So those are the two we've already done. So those are different ways to prove two triangles are congruent. And sometimes they're apart, but more than likely you will see them together. Okay, so if two angles, and this is the angle side angle, if two angles and the included side, this time not the included angle, but included side, so if you can see this, this is angle, side, angle, and the side is included because it's between. So side, between my two angles. So angle, side between, and then angle. Of one triangle are congruent with the two angles and the included side on the other one, like this, then they are congruent. Okay, most likely in a proof you're going to see them look like this. And you're going to know that these two angles are congruent. And why is that? Because of vertical angles. Therefore, I now have angle, side, angle. Okay. Next, angle, angle, side. If two angles and the non-included side of one triangle are congruent to the corresponding two angles and a side of a second triangle, then the triangles are congruent. So, and it has to be like, what's the word? Hold on. Consecutive. So we have angle, angle, side. Angle, angle, side. Consecutive. So it's not like hopping around here. So as you can see, B and E go together, A and D go together, and then this one goes together. So this is angle, angle, side. And that's how you can prove it. Again, these are not going to look like this. They're going to look like this when you go to prove. So on this one, you have these two angles, this two angles, and a side. So angle, angle, side. Angle, angle, side. And that's how you know they're congruent. All right, hypotenuse leg. Hopefully you know if this only applies to a right triangle. If the hypotenuse, I'm going to shorten that, and a leg of a right triangle are congruent to the hypotenuse and leg of the second triangle, then the two triangles are congruent. So, right and a leg, this. Then these two, your hypotenuse would be congruent. So this side is your hypotenuse. Okay. So here, since these two, and this is a right triangle, well, this would almost be reflexive, but you should know that these two would be equal to each other. Okay. Hypotenuse, leg. And you can see that by the 90-degree would be like your hint. Okay. Let's see. Proofs. Let's go ahead and try to understand this first. So this is the midpoint of WE. And WR is congruent with this. So this line and this line are parallel. Okay, so we need to prove that these two angles are congruent. Again, we know that these two are going to be congruent because of vertical angles. Let's see, L is the midpoint, so that's given. The second thing we could say is that WL is congruent to LE. WL is congruent to LE, and why is that? That midpoint theorem. Okay, you guys can't see what the heck I'm doing. That could be a problem. There we go. This is also given. So what do we know about alternate interior angles? Let's say that this was our transversal. We'll just use this one as an example. You should know that this and this are the same. Okay? So that would mean that angle RWL is congruent to angle DEL. We also said that WR is congruent, I forgot to mark that one, to ED. Okay. What's next? Alternate interior angles. We know that angle L is congruent with angle L, and that would be vertical angles. And then we could say we have angle, side. It has to be consecutive. So you could not say angle, side, angle, because this is not included between the two. This is consecutively. So angle, side. WL angle, side, and that is WRL is congruent to triangle EDL. Okay, next, more proofs. Let's write these out. Make sure you can see this. Okay, so in KL, I gotta watch myself. In KL, so that triangle is congruent with NJM. I think I might want to do a congruent statement. Oh, those are angles. So NKL is congruent to NJM. So that means these two angles are congruent. That's exactly what that is saying. Side KL, where's KL, is this side, is congruent to JM, to this side. So how can we prove that side LN is the same as MN? Seems kind of weird, doesn't it? So we just said all of those things. What else can you tell about this? One you probably didn't think about is that this is congruent to itself. Because it's on both triangles, it's almost like they're sharing it, that angle here. So we could say that angle N is congruent to angle N, and hopefully you know that's reflexive. What else can we see? That the triangle JNM, so now we're talking about JNM and triangle KNL are congruent to each other. So how did we prove that? Angle, angle, side. And the last thing you can say, LN is congruent to MN by proving those parts, those congruent, it's like proving those congruent parts makes those equal to each other, and that's that CPCTC. Okay? Next. Let's do this next one. Let's mark it. Again, you have to, if pictures are not given, you need to draw the pictures. Having the scratch piece of paper is going to be huge. This one is completely empty, so we're going to have to be real careful. This picture is not very big and you can hardly see it. But obviously you see that these two are the same. Those are hypotenuses. Here's our right triangles. So it's going to probably have something to do with that hypotenuse leg. So let's write down our statement here for our given. So MN is congruent to OR. MN is congruent to OR, so that's already marked. And then angle MON, so the O is congruent with the N. So that we know that because they're 90 degrees. And that's given. That's already in the picture. We could also say that ON is, since they share, you kind of look for things that they share so you can do that reflexive. So this line, I can't get in there, but we're going to say line ON is equal or congruent to itself, and that would be reflexive. And then we can say that the triangles are congruent. So this, if you're trying to prove something equal, you have to prove the triangles are equal. If you're trying to prove the triangles are equal, then this would go first, and then your proof. So MNO is congruent to triangle RON by hypotenuse leg, and therefore we can say that MO is congruent to RN because of that CPCTC. Okay, so this is proving triangles are congruent. So sometimes you just don't know which way to go here. All right, so let's look at this last one. The curtain decorating the window forms two triangles. I see them. They're very light. They're here and here. At the top, B is the midpoint. Great. Of AC. AE is equal to 13. CD is also 13. BE, this, and BD each use the same amount of material, 17, 17. Obviously, these are right triangles. Which method would you use to prove? So, does it say it's a right triangle or it doesn't say? Two triangles, right triangles. So if these two are the same sides, right, you would know that this is equal to this. So that would be side, 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 because of the two sides are equal, then third side is equal. Do we have more? I think that's it. You think that's enough? Good luck on your assignment. Please ask me questions if you need to. All right, so moving on to 4-6. I thought that was enough, but obviously there's more. Let's see. Isosceles and equilateral triangles. So make sure that you know, like this would be considered your vertex, and this is considered your base. So if two sides of a triangle are congruent, so we're not comparing, a triangle with another triangle. So we're just talking about a triangle in itself. So if two sides of a triangle are congruent, then the angle opposite would also be congruent. So this side goes to here, and then this side goes to here. If these two are equal, that means those two angles would also be equal. Next, the converse of that. If two angles of the triangle are congruent, then the two sides, so it's the opposite of that. So this would be the opposite sides. So this is opposite of here, and this is the opposite of there. Equilateral. A triangle is an equilateral if and only if it's equiangular. Equiangular. That's this whole concept. So this goes across, this goes to this side, this goes to this side. And then each angle of an equilateral triangle must measure 60. That's the only thing it can be, because they have to equal 180. Okay. All right, so name two unmarked congruent angles. So we could say angles B, C, A is not marked, and it's congruent to angle B, A, C, unmarked congruent. B, C, A. Okay, I am going to mark these. This is going to go with C, and then where's my other one? This would almost go with D. So this goes to here, correct? Because of this angle. This would go to here, and this one would go to here. Name two unmarked congruent segments, same thing. So this would go to this side, this would go to, where's my other one? That goes with that angle, this goes with that angle, this goes with that. That's only one. Where am I missing one? I feel like I'm missing one. BC, BC, and DB. This one's already marked. Anyway, I think we're good. Just trying to look at this again. Name two unmarked congruent angles. I think we just marked them. I hope that's good enough. Moving on. Find the measure of angle R. Well, if this is 60 and this is 5, obviously this is going to be equal to this, which means they all have to be 60. Find PR. Obviously it's going to be the same since they're all the same. That one makes more sense. Okay, find the value of each variable. Okay, this is stuff that you're going to do. It says all of these are equal. that means all these angles are equal to each other. And then all the sides are equal to each other. So should we do an angle? These two together are 60. Okay, so we know that this plus this equals, so that's got to be 60. This has to be 60. So that's 120. So we could add those up to be 120 together, or just one of them equal to 60. That seems easier. Okay, there's X. So since this is all equal, angular, equilateral, that means my angles are equal to 60. And then my sides are all the same, but we have no idea, but they're all equal to each other. So I'm going to take this side equal to this side. So 8y minus 5 is equal to 6y plus 3. I always take the smallest variable over. I'm going to add 5 equals 8, y equals 4. And there you go. All right, proof time. So this one is pretty bare. Lots of stuff here. Let's read it. So CD is congruent to CG. So those are the same. So this looks like this whole big thing is an isosceles. Okay. DE is congruent to GF. Okay, it's already marked. And we're going to prove that CE is congruent to CF. So we're going to prove that since this is an isosceles triangle, I bet we're going to prove that D and G are equal because of the isosceles. Okay, so let's give our proof. Given CD is congruent to CG. Given. There's two givens, so let's go ahead and put the other one. DE is congruent to GF. Okay, so we can say that angle D and G are the same. So angle D is congruent to angle G because of the isosceles theorem. And then this was given. And then we're going to prove that angle, the whole triangle, CDE is congruent to triangle CGF because we have side angle side. And then again, how do we know that these two are congruent? Because they're part of the parts. CPCTC. It's those parts. Okay. Now I'm done. All right. Talk to you guys later. Let me know if you have any questions.